Welcome back. Myself Dr. Sayanti Chatterjee, and today I am going to start the topic of electromagnetic field theory, the definition and terminology on dipole current density and capacitance. I am Sayanti Chatterjee, the Associate Professor of Electrical and Electronics Engineering Department, IARE, Hyderabad. So before starting the definition and technology, my first definition is, as the name suggests, define the electric dipole. What is electric dipole? Two opposite charges plus q and minus q means two opposite charges of same value but opposite in sign are separated by some distance forms a electric dipole. So the two things should be must. First of all, the charge should be have the same value plus q and minus q. Both the charges should have the same value and they are magnitude wise they are same but their sign is opposite. One is plus q, another one is the minus q. The distance traveled by the point charge is defined as the dipole moment. So while the word comes dipole, the another word comes the dipole moment. The distance traveled by the charge is defined as the dipole moment, or the product of the charge and distance traveled by it calls the electric dipole. So what is electric dipole? Say we have two charges. One is plus q, another one is minus q. So, and the distance between them is x. So, if the both charges have the same value, they will create the electric dipole. And the distance between them is x. Then the q into x magnitudes and the distance traveled, magnitude and the distance traveled by both is known as the electric dipole. So if the distance is d, electric dipole is equal to P is equal to Q into D. P is the electric dipole moment, Q is the charge magnitudes of the charge, and D is the distance of the two charges in the opposite sides. That's why these two charges is called as the axis of dipole. So, this is known as the axis of dipole. So, is known as the axis of dipole. So, in short, the electric dipole means if the two charges of equal magnitudes but opposite in direction are separated by a distance d, they will form an electric dipole. Electric dipole means, and what is electrical dipole moment? The distance traveled by the point charge or the product of the charge and distance traveled by it is called the dipole moment. P is equal to Q into D. Now we are moving to our second definition. Give the relationship between the electric field intensity and electric potential. This is the basics. This is the base of the electromagnetic theory, the basic definitions. So electric field, what is electric field intensity? Electric field intensity means to the work done to bring one unit charge from one point to another point. This is known as the potential. So potential means to bring one unit charge from infinity to one electric field. And what is electric field? The work done or the energy required to the force required to bring one unit charge in the electric field. So there is some little bit same definitions. So what is the relation between them? Electric field intensity is equal to the negative rate. This is the one very important term. The negative rate of change of potential with respect to the distance. The negative of rate of change of potential. So we can write E is equal to minus dV by dr, where V is the potential difference is E, field intensity is E, and R is equal to distance. That's why the unit of the intensity is known as the volt per meter. Volt per meter means the voltage per unit length. So electric field intensity is equal to the negative rate of change. Now, in the practical case, the charges is in the 3-dimensional. So we can't define the field intensity in the one-dimensional thing. So field intensity in the vector form is equal to E is equal to minus grad V, or we can write like minus grad V. What is the meaning of grad? Grad means the differentiation with respect to x, with respect to y, and with respect to z. So if there are 3 axes x, y, and z, the grad means del by del x plus del by del y plus del by del z. So for the vector form or for the 3-dimensional, the EMF is equal to minus grad of V. So this is the definitions of the relations between the electric field intensity and electric potential. E is equal to minus grad dot V, and unit of E is equal to volt and unit of V is equal to R. Now we will move to our third definition. Define polarization. When we know about the electric field, now we know about dipole, the next important questions comes into our mind is what is the meaning of polarization. So before telling the definition, I will first tell the concept. Say we have a charge here and another one positive charge here and another negative charge is there. Both have the same magnitudes and there are some distance between them is d. So what will happen? The general tendency of the two charges will be attracted by them. And if there is some dielectric medium between them, they cannot come together. So what will happen? Their center of gravity will change like this. Their center of gravity will change like this. And this is known as the polarization of the charge. So before starting, so what is the definition? So according to the definition, we can tell if the dielectric or insulator placed between the charges of a condenser, another name of the condenser is, so condenser is nothing but the capacitor. So if the dielectric or insulator is placed between two condensers, say parallel plate condenser, then the center of gravity of the negative charges as well as positive charges will change. The CG of negative charges will comes towards the positive charge and the center of gravity of the positive charge will comes towards the negative plate. So as a result, the process of separation of opposite charges is known as the polarization, as I told just earlier. Polarization can be also defined as the electric dipole per unit volume. So already we know what is electric dipole. If two equal charges are d centimeter apart, there is, if two equal charges of opposite signs are d centimeter or d unit apart, there will be some polarization. An electric dipole is equal to magnitudes of the charge into the distance between them. If so, electric dipole moment P is nothing but the Q into D, where if there are two charges plus Q and minus Q and the distance between them is D. And if the electric dipole moment per unit volume is known as the polarization. polarization is also defined. So let A is the cross-sectional area of the dielectric. I is the distance, or L is the distance between the opposite charge. This distance, we are assuming this distance is L. So what will be the volume? Volume is equal to cross-sectional area into distance. Now what is dipole moment? If the distance is L, it is Q into L. So we can write the definitions of the polarization. The definitions of the polarization: P is equal to dipole moment per unit volume. So Q into L divided by A into L is equal to Q into A. The dipole moment is numerically, definition wise, it is the definition electric dipole per unit volume. Numerically, we can tell that it equals to charge per area. So what is this? This is nothing but the surface charge density, and its unit is coulomb per meter square. So mathematically we can tell that the polarization is nothing but the surface charge density. So what is polarization? Just one quick review. Polarization means if there are any dielectric or insulator in between two capacitor, the positive Cg of the positive charge leans towards the negative charge, and the Cg of the negative charge will comes near to the positive charge, and this process of separation of charge is known as the polarization. Polarization can be defined as the electric dipole per unit volume. So volume, if the cross-sectional area of the plates are A and the distance is L, so volume is equal to A into L. What is the electric dipole? Electric dipole means if two equal and opposite charges are L unit apart, then we can tell the dipole moment P is equal to Q into L. So what is the polarization? Dipole moment per unit volume. Q into L divided by A into L is equal to Q by A. Again, from the unit 1, we know Q by A is nothing but the surface charge density. So numerically, the polarization is equal to surface charge density, and its unit is coulomb per meter square. Next, we will move to our next definition, and next definition is the permittivity of the medium. What is the permittivity? Permittivity is basically some characteristics of the medium, of the insulator or dielectric medium. So definition wise, the ability of a substance, especially the dielectric or insulators, to store electrical energy in the electric field. Actually, in the capacitor, in the dielectric, energy is stored, and in the resistor, energy is dissipated. So the ability of a medium or substance to store electrical energy is known as the permittivity of the medium. So permittivity is basically two types. One is known as the absolute permittivity, and another one is known as the relative permittivity. Absolute permittivity means the permittivity of the vacuum or air. It can be written by epsilon, and epsilon value, epsilon naught, and its value is 8.854 into 10 to the power minus 12. What is the relative permittivity? The permittivity of any medium with respect to vacuum or air. So what is relative permittivity? The permittivity of any medium with respect to vacuum or air. And what is the permittivity of the medium? Permittivity of the medium is epsilon 0 into epsilon r. So say if we tell the permittivity of oil is 2, it's what is the actual permittivity? The actual permittivity of transformer oil is 2 into 8.854 into 10 to the power minus 12. So this is the permittivity. And what generally for any problem, if permittivity is not given, we will assume it is in the air or vacuum. So this is the general definition of the permittivity. Now we will move to our next definition. Define the dielectric constant. This is a very important definition. What is the dielectric constant? So, dielectric constant is we can define the dielectric constant in the different manners. Dielectric constant is the ratio of the capacitance of the capacitor with dielectric to the capacitance without dielectric. So the definition is little bit clumsy. Please try to understand. Dielectric is defined of the ratio of the capacitance of a capacitor with dielectric to the capacitance of the capacitor without dielectric. Or without dielectric means between two parallel plates there is nothing but the air. Or we can define as the ratio of the, and this is also known as the relative permittivity. So dielectric constant is same as the relative permittivity. So what is relative permittivity? Already we know, the permittivity of the substance to the permittivity of the free space. Permittivity of the substance to the permittivity of the free space. So we can write epsilon is equal to epsilon R is equal to epsilon by epsilon 0. So this is also known as the dielectric. So what is dielectric again? The characteristic of any medium or any substance to store the electrical energy. As this is a ratio of the two same type of things to equal to same like entities, it is basically unitless, or we can tell it is a dimensionless quantity. There is no unit of the dielectric constant. On the other hand, we can also write the capacitance in the form of the capacitance. We can also write the capacitance for a parallel plate capacitor is equal to epsilon A into D. Capacitor with any medium. What is capacitor with air or capacitor without dielectric? It is epsilon 0 A by D for the same plates. So what is the dielectric constant definition? Dielectric constant is equal to Cm by Cr. So is equal to epsilon A by D divided by epsilon 0 by D, and we are getting epsilon by epsilon 0. The same thing we can get from here. So we can tell the dielectric constant is the ratio of two things. Next definition. So we have now coming to the capacitor, and the next question comes, what is the capacitance of the capacitor? Capacity means to store something. What is the meaning of the word capacity? The capacity of a bag, the capacity of your workload. Capacity means to hold something. So what is the capacitance? Capacitance means the capacitance of a capacitor is defined as the charge Q developed between the plates when the voltage V is applied. If we have two parallel plates or two concentric plates, whatever, if we connected it with any voltage source V, there will be some charge, and the charge per unit potential is known as the capacitance. The basic capacitance element is formed by separated two parallel plates with some dielectric medium. It may be air, it may be porcelain, it may be wood, anything, but there are some medium. When some voltage applied to such an element, charge is formed between the plates. Capacitance of the capacitor, as I told, Q developed between the plates when V is applied. So we can write C equals to Q by V. And what is the unit of the capacitor? The unit of the capacitor is generally farad. But we can also use the value of the microfarad, picofarad, these things, nanofarad for our application. Microfarad means 10 to the power minus 6 farad. Picofarad means 10 to the power minus 12 farad, and nanofarad means 10 to the power minus 9 farad. So the units of farad, which is generally the unit is farad, but for our day-to-day life, for buying any capacitor, we generally prefer 3 units: microfarad, picofarad and nanofarad. Next, the capacitance of the parallel plate is dash. So before telling, this is the diagram of the parallel plate capacitor. You can see there are 2 parallel plates, and in between there are some slabs. There are some distance d, and this is the dielectric of the medium. So what is the capacitance between the parallel plates? Capacitance of the parallel plate is C equals to epsilon A by D. C equals to epsilon A by D. So, let the potential we are giving, the applied is V, electric flux density between the plates. What is the electric flux density? D is equal to Q into Q by A. What is D? D is equal to Q by A. We know D is equal to Q by A, and what is D? D is nothing but the epsilon into E. So D is equal to Q by A is equal to epsilon into E. So we can substitute it Q by A into E into epsilon. Q epsilon A into V. So after putting the value, the capacitors is C is equal to Q by V, and we are getting the value C is equal to epsilon A by D, where D is the distance between these two, A is the cross-sectional area of the parallel plate. So capacitance of the capacitor is epsilon A by D. How we are getting this? I will write it once again. First, what is the flux density? Flux density is equal to psi is equal to charge per unit area, Q by A. Again, what is D? D is nothing but the epsilon E. What is E? E is nothing but the Q by epsilon into A. We got Q into epsilon into A. Now we are discussing about the V. What is V? We have already discussed. V is equal to, actually we discussed in the previous, E is equal to dV by dr. If we are not taking the magnitudes, or we can write voltage we are applying between the plates by the distance between them, V by D. V is equal to then E into D. So we can write V by D is equal to Q by epsilon into A. So what is V? V is nothing but the Q D by epsilon A. Now we know Q by V is equal to capacitance. We know Q by V is equal to capacitance is equal to epsilon A by D. So from here we can also deduce the capacitance value, that is C is equal to epsilon A by D. Next, state the Stokes Theorem. The Stokes Theorem is very, very important for all chapters. The Stokes Theorem states that the surface integral of the curl of a function over a surface bounded by a closed path, it is the one important thing, is equal to the line integral of the particular vector function around the surface. So there is the one important term, that is the line integral of a particular vector. So around the surface, the Stokes theorem says that the surface integral of any function is equal to the volume integral of the divergence of the same. What does it mean? That if we want to do the surface integration of fx dx, is a surface integration over a closed surface is equals to the volume integration of grad of fx into dv, or we can write the line integration of dx is dl, this is ds, is equal to the surface integration of fx dx. So Stokes theorem can be used to turn the surface integral into through a vector field into the line integral, or we can change the volume integral of the divergence from the surface integral. So this is the Stokes theorem. Using the Stokes theorem, we can change the one integration level to another integration level. Okay. Write the expression for the capacitance of the coaxial cable. Coaxial cable is a very important important example of the capacitor. In here, you can see there are two capacitors. And this is the inner two plates, and they are looks like the cable. One is the outer cable, one is the inner cable. The inner cable cross section is radius is A, and the radius of the outer one is the B, and epsilon r is the permittivity of the medium, where epsilon is equal to epsilon r into epsilon 0. The length of the capacitor is given as L. So the expressions of the capacitor is equal to 2 pi epsilon divided by ln B by A, where B is the radius of outer cylinder. And what is A? A is the radius of the inner cylinder. What is epsilon? Epsilon, as I told here, epsilon is equal to epsilon r into epsilon 0. So this is the expression of the capacitance of an coaxial cable. Coaxial cable is used in the case of the underground cable, is the very good example of the coaxial cable, where this is the copper wire and this is the PVC based, and in between there are different layers of the dielectric of the difference relative permittivity. Next. What is the relation between electric flux density and intensity? So, write the relation between electric flux density and intensity. The relation between the electric flux density and intensity D is equal to epsilon into E. Now, how to get this one? Already, according to the Gauss law, D is equal to flux density is equal to D is equal to flux density. This is our D, and this is the field intensity. We write with E. So D is equal to flux density is equal to psi by density, means by cross-sectional area. Now, according to the Gauss law, the number of electric lines of force or electric flux equals to charge enclosed. already we know from the unit 1. So psi can be equals to the Q by A according to the Gauss law. So Q by A. So what is D? D is equal to Q by A. And as our earth is a looks like a spherical, so if any the shape of the surface is not given, by default we check the surface is looks like a spherical. So what is the cross sectional area of a sphere? 4 pi r square. So we can write D is equal to Q by 4 pi r square. Now what is the meaning of intensity? According to the Coulomb's law, the force required to bring one unit charge from one point to the electric field. So according to this, E is equal to Q. Actually Coulomb's law is equal to Q1 Q2 by 4 pi epsilon r square. But as the one charge is unit charge, so Q by 4 pi epsilon r square. So if we compare these two results, so if we do the T divided by E, we get the value epsilon, and so we got the answer D is equal to epsilon E. So this is the relation, and this relation is very, very important in the case of the electromagnetic field. Next, write the expression for the energy stored in the capacitor. So by the definitions of the capacitance of the parallel plate is C is equal to Q by V, or V is equals to the electric potential. And we know V is equal to dW by dQ. What is potential? The work done to bring one charge from one point to another point. So what is dW? dW is equal to V into Q, dQ. And what is V? Already we got V is equal to Q by C. V is equal to Q by C. So if we substitute the value, we got dW is equal to Q by C into dQ. Now if we integrate the both side, by integrating the both side, what we will get? Integration of Q by C into dQ. So Q by C, 1 by C is equal to constant, Q square by 2 into, this is the W means watt. Now what is again Q? Q is equal to nothing but the C into V. So if we put the value, we get Q is equal to CV whole square by 2C. Or we can write W is equal to half CV square, or we can write that half Q square by C, or we can write half V into Q. So there are the different definitions of the energy stored in the capacitor. First definition which we used more, Q is equal to half CV square, or we can write Q is equal to half Q square by C, or what we can write, half into V into Q. So this is the definitions of the energy stored in the capacitor. And then what is the unit of the energy stored in the capacitor? Energy stored in the capacitor is, again, the unit is nothing but the joule. Joule is the unit of the energy stored in the capacitor. Next definition. Write the energy density in the capacitor. So we know energy density in the capacitor can be written as the energy stored per unit volume. Energy stored per unit volume is known as the energy stored. So from the previous, I will just recap it little. So just I will recap it. The capacitance, we know capacitance is equal to Q by V. And what is the work done? What is V? V is equal to D work done by dQ. So we can write dW is equal to V into dQ. Already we have discussed, just one quick recap. So what is V from here? V is equal to C into Q. CQ into dQ. So what is, if we integrate the both side, what we will get? We will get W is equal to C Q squared by 2. Now, what we can write from here? Or we can write V is equal to, not C, Q by C. P is equal to Q by C. So what we will get here? Here we get that Q squared by 2C. We got up to this. So this is the energy stored. Or we can write that this is equal to half C into V square. How we can get this? Q is equal to C into V. What is Q? Q is equal to C into V whole square by 2C. So half CV square. Now what is the energy density? Energy density is nothing but the energy stored per unit volume. So what is energy stored? Half CV squared divided by volume. Volume means A into D. If it is a parallel plate capacitor, this is the cross-sectional area is A and D is the distance between the parallel plate capacitor. So we can write CV square by 2 into volume. So what is CV square? CV square, again what is C? C is nothing but the epsilon A by D. So if we put the value here, we will get epsilon V square by 2D square. Again, we know V is equal to E into D. So if we substitute the value of V with E into D, we will get epsilon E square by D square by 2D square. So D square will cancel out and we will get epsilon E square by 2. Now epsilon E, what is epsilon E? We have discussed. Epsilon E is nothing but the flux density D. So D into E by 2. So define the energy density in the capacitor. We need 4 important formula of this topic. First one, V, the voltage is equal to dW dQ. This is our first important equation we need. What is the second important? C is equal to Q by V. So just we are doing the substitution and we got the W is equal to the energy stored is equal to half CV square. Now the definition, according to the definition, WD is equal to energy stored per unit volume. We are just putting the value and we are getting CV square by 2 by AD. Now what is C? C is nothing but the epsilon into A. We are just putting the value and we got the epsilon V square by 2D square. Again, V is equal to E by D. So while we are substitute the value, we got the equation WD is equal to epsilon E square by 2. And according to the Gauss law, the last important definition is equal to D is equal to epsilon E. So epsilon E is equal to D and WD is equal to half D into E. So this question is very, very important for the any type of competitive exam. They may ask the energy, calculate the energy density from any of this type of formula. It may use the half CV square, you may use the epsilon half DE, whatever, but the many questions will come from this topic. So we are moving to our next topic. What is current density? So current density is nothing but the current per unit area. For the simplicity, we can tell if the charge is distributed in the given area, the current density is defined as the current constituted in the area. So, if the charge is distributed in a group, current means the flow of charge, and whenever there is a flow of charge is there, the current density is defined as the current constituted in the given area. And current density can be written as the J is equal to I by A. The unit of I is equal to ampere. The unit of A is equal to meter square. So it will be A by meter square. And one important thing we have to remember here, the current density is always written by capital J. The current density is always written by capital J. Why? Because the current small j in the electrical, the small j indicates the the j operator is equal to root of -1. That is the imaginary quantity. So for the electrical, current density is a very, very important thing, and current density is always depends on the j is equal to I by A. It is always the capital J, never use the small j for the current density. So we can write from the current density, A is nothing but A means the surface area can be written as the di by ds. So current is equal to integration of j into ds. Now the question is the classify the current density. Current or current density can be divided into the three parts. One is the convection current, one is the conduction current, one is the displacement current. Convection current means that is the conventional. So convection current means while there is a normal circuit, there is a flow of charge, current will start to flow, and this current is known as the convection current, and the current density of the convection current is known as the convection current density. What is conduction current? Conduction current is nothing but if we force the charge to be mobile, charge is not moving, we are forcing it to be the mobile. While we are switching on the circuit, we are giving some potential to move the charge so that current can flow. So conduction current density means the charge due to the current density due to the mobility of the charges. This is known as the conduction current density. Last one is the displacement current density. Displacement current density means it is through the dielectric medium. Generally, there is no current flows through the dielectric. But while any capacitor is connected with any source, there are a very little amount of current will leak through the dielectrics. This current is known as the displacement current, and displacement current is written by the JC. Displacement current density is written as the JC, and the conduction current density is written by the JD. Current density J is equal to the summation of JD plus JC. The use of the convection current is very less. Generally, current has two parts. One is the conduction current, another one is the displacement current. Define the conductor and write its property. In the simple term, an electrical conductor is defined as the materials that allow electricity to flow in it slowly. This property of the conductors that allow them to conduct electricity is known as the conductivity of the mediums, and the flow of the charges through the conductor is known as the electric current. A conductor exhibits the following properties. A conductor always allows the movement of electrons and ions in it. The electric field of a conductor is zero, allowing electrons to flow within them. Why? The general tendency of the flux is to lie outside of the surface of the conductor. So, within the conductor is zero, allowing electrons within them. Inside there is mathematically the charge is zero. The charge density of a conductor is zero. Third important point is the charge density. No charge is accumulated in the conductor. Only on the surface of the conductor free charges is there. Free charges always is on the top of there, and the points of all the points of the conductors are at the same potential. So the materials are the example of the conductors. So conductors. This is the reason why the appliances bodies are generally made of metals. The wood metals, copper, aluminium, these are the good conductor of the electricity. The plastic, we are using the plastic covering surrounding the electric metal to prevent from the electric shock. So in this chapter, what we have discussed about the dipole moment, the relation between the electric field intensity and the potential. Then fourth question, we have discussed about the polarization. Then we have discussed about the capacitor, the energy stored in the capacitor, the energy density of the capacitor. Then we have discussed about the current density. Next, we have discussed about the current density, different types of current density. Also, we have discussed about the dielectric constant, and we have discussed about the different types of the permittivity. And the last important question, we have discussed about the what is conductor and what are the properties of the conductors. So these are the all of the definition and terminology important questions from the unit 2. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.